Hello friends, how are you doing? In this video we will start studying about polar plot. So polar plot is one among the graphical technique to study the frequency response of any transfer function. Earlier we have seen a Bode plot technique. Bode plot was nothing but in Bode plot we will try to plot the variations in magnitude as well as phase in two separate plots called as Bode magnitude plot and Bode phase plot. In Bode magnitude plot we used to plot the variation in magnitude versus frequency. And in Bode phase plot, we used to plot changes in phase angle with respect to frequency. So Bode plot consists of two individual plots, which is called as magnitude and a phase plot. So that is about Bode plot. So next plot is a polar plot. So polar plot is also a graphical technique or a plot which is used to analyze the frequency response of an open loop transfer function. So polar plot is a graphical method of finding frequency response of open loop transfer function. So whenever you're dealing with polar plot, whenever you're constructing polar plot, you have to deal with the open loop transfer function. Sir, the finding out of stability does not arise for open loop transfer function because the main intention of control system is only to study the effect of the system or the behavior of the system after inclusion of the feedback. So feedback is the heart of control system subject. So when you are making the open loop system into open loop closed loop system, then you are supposed to find out what is the stability. But how can you say that when you are analyzing about open loop transfer function, you can estimate the stability of the closed loop system? Yes, we can do that. What is open loop transfer function? Open loop transfer function is nothing but g of s into h of s, where g of s is the forward path gain, h of s is the feedback path gain. Understood? That means you are studying the effect of feedback also, the feedback path also. That means if you are trying to find out the open loop transfer function frequency response, it will actually help you in determining or to analyzing the closed loop system stability also. So I can write it helps in the study of closed loop transfer function stability. Okay, up to now it is okay. Sir, then what are we going to do in polar plot? Like we have already discussed in Bode plot, we are actually trying to plot the variations in magnitude and phase with respect to frequency. But what we are going to do here? So when you talk about Bode plots, you are having two separate plots, that is magnitude plot and phase plot. Whereas polar plot is a combination of two plots. It is combination of both magnitude and phase of the transfer function. How we are going to do that? How we are going to do that means, let us try to draw the graphical coordinate system which is used to study the polar plots. So this is this coordinate system. So you are having the x and y axis. So this x axis represent the real part of the magnitude. Okay, it represents the real of the magnitude of the transfer function, and this is the imaginary of the transfer function, imaginary of the magnitude of the transfer function. This is minus imaginary and this is minus real axis. So we know these things are already known to us. Again, on this same coordinate system only, if I am supposed to write the phase angle, how will the phase angle will be? So the phase angle of this axis will be how much? It will be 0 degrees. What will be the phase angle of this axis? The phase angle of this axis will be minus 90 degrees. What will be the phase angle of this axis? Minus 180 degrees. What will be the phase of this angle, this axis? It will be minus 270 degrees. This is when you are moving in clockwise direction. Let us say you are moving in anti-clockwise direction, then what it will be there? So when you are moving in anti-clockwise direction, from 0 to anti-clockwise direction, this will be how much? Plus 90 degrees. So minus 270 degrees or plus 90 degrees is the same axis. Similarly here, this will be plus 180. So plus 180 minus 180 does not matter. Both are the same. What will this be equal to? This will be plus 270 degrees. Again, this will be 360 degrees. So 360 or 0 degrees are the same. Understood? We are actually trying to plot the variations of magnitude as well as the phase angle of the system of the transfer function in a single plot like this only. Therefore, this polar plot also known as magnitude versus phase plot, and you are plotting magnitude and phase plot under what condition? By varying the frequency, isn't it? That means if the frequency is varied from 0 to infinity, so this is our range of study. We will be varying the frequency from 0 to infinity and we will be checking how magnitude versus phase plot is changing on this graph. So polar plot is basically defined for in frequency 0 to infinity. So there is daddy of polar plot which is called as Nyquist plot. So Nyquist plot is the dad of polar plot. What does this dad do? Dad is same as what the sun does, or I can say sun is same as the dad. What is the sun doing? It is doing the variation between magnitude and phase as the frequency is changing. So the coordinate system is the same for Nyquist plot also. It also does the same thing. It is going to plot the changes in magnitude and phase angle while the frequency is varying on the same plot, on the same graph. But the range of frequency is different. The range of frequency for Nyquist plot will be from minus infinity to plus infinity. That means there are two parts over here. One is minus infinity to 0 and there is 0 to plus infinity. So that part of Nyquist plot which is existing for 0 to plus infinity omega is the polar plot, and that one which is existing for 0 to minus infinity is inverse polar plot. So the combination of polar plot and inverse polar plot itself is the Nyquist plot. Therefore, polar plot is a part of Nyquist plot. That is the reason why when you look at some questions, examinations, instead of giving you polar plot, he will tell you the Nyquist plot. For example, take this only. This question was taken from ES 2001. In this question, he is telling that he has given some open loop transfer function and he is asking you to identify which represents the Nyquist plot of the system. See, Nyquist plot is basically a plot existing between minus infinity to plus infinity omega. That is cool. But polar plot is something from 0 to plus infinity only, and polar plot is a subset of Nyquist plot. That means a polar plot may be called as a Nyquist plot, but a Nyquist plot itself is not called as a polar plot. Okay, please make this point clear. So as I was telling you, 0 to plus infinity is polar plot and minus infinity to 0 is inverse polar plot. This polar plot and inverse polar plot are actually mirror images. So this minus infinity to 0 is a mirror image of this polar plot about real axis. Let us say the boundary between these two is a real axis like this. Below the real axis, if you are having polar plot, on the top you will have the inverse polar plot or nothing but the mirror image. That means I can say Nyquist plot is a symmetrical plot and it is symmetrical about real axis. Nyquist plot is symmetrical about real axis. Please note that one, that will become a very important MCQ for some exams. Now let us try to solve this question which is given on the board. So in this question, he has given you an open loop transfer function g of s is equal to s by 1 plus s, s by 1 plus s. So what I will do is, I will write it in the form of g of j omega. That means simply instead of s I will put j omega. So if I put j omega, then the transfer function converts like this. So this is the transfer function. So whenever you are having this transfer function, as I was telling you, we are in polar plot trying to plot the variation of magnitude and phase together in a single graph, and that too by varying the frequency from 0 to infinity. So let us first write down the expression for what is the magnitude of this expression. So the magnitude of this transfer function will be omega by under root 1 plus omega square. This is the magnitude. Are you satisfied? Yes. Now let us look at the phase angle of this system. So phase angle will be j omega. It is directly the imaginary part. So the phase angle is inherently 90 degrees and minus, because now you have to subtract for the denominator phase angle also. Denominator phase angle is, this is, you see, this will be tan inverse of imaginary part by real part. So omega by 1 is omega only. So this is the phase angle of this system. Okay, are you satisfied? Yes. But in fact, when you are actually doing the problems, the tan inverse of omega will yield you the value of angle in radians. If you want to convert into degrees, what you have to do is, you have to multiply by 180 degrees by pi radians. Then you will get the value in degrees. You have to please make that point also clear. Now what I am going to do is, I am going to take two boundaries of frequency, that is minimum and maximum frequency. What is the minimum frequency which we will be studying? 0. What is the maximum frequency? Infinity. As I was telling you, the polar plot exists between 0 to infinity frequency only. And under 0 and infinity condition, let us see how the phase and magnitude are varying. So if I put omega is equal to 0, what is going to be my magnitude? Magnitude is going to become 0. What shall the phase angle going to become? Tan inverse of 0 occurs at 0 degrees. So tan 0 becomes 0, isn't it? So at 0 degrees, that means the phase angle become how much? 90 degrees. At omega is equal to infinity, what is the magnitude? So to put magnitude omega is equal to infinity, what I will do is, I will just take omega square common in this denominator term, then it will become like this. So omega into 1 minus 1 plus 1 by omega square, isn't it? Can't I simplify like this? So I will just try to cancel out this omega on the numerator by doing this kind of approximation. If I put omega is infinity, so 1 plus 1 by infinity will become 1, and the magnitude 1 by 1 will become 1 only. So magnitude is going to become 1 over here. Next, phase angle when omega is equal to infinity. When you will get omega is equal to infinity? When angle is 90 degrees. So 90 degrees minus 90 degrees is how much? 0 degrees. So you got angle how much? 0 degrees. So finally we got the required boundary conditions. So at omega is equal to 0, the magnitude is 0, but the angle is 90 degrees. What 90 degrees? It is plus 90 degrees. When omega is infinity, the angle, the magnitude is 1 and angle is 0 degrees. And always keep in mind, polar plot starts from omega is equal to 0 and ends at omega is equal to infinity. So the starting point of the polar plot is given by the omega is equal to 0 and ending point is given by omega is equal to infinity. So let us try to see where the graph will start. Graph will start at 0 magnitude and at plus 90 degrees, isn't it? Omega is equal to 0. So look at the graph where you are having magnitude 0 on plus 90 degrees line. So which is the plus 90 degrees line? Or let us try to draw it here only. So this is my coordinate system. So where is plus 90 degrees? This is plus 90 degrees, isn't it? So on plus 90 degrees, the magnitude is how much? 0. So on this plus 90 degrees line, your magnitude is 0. So this point corresponds to omega is equal to 0. Next, when omega is infinity, magnitude is 1 and which angle? At 0 degrees. So where is 0 degrees line? This is the 0 degrees line. On the 0 degree line or on the 0 degrees, what is the magnitude? 1. It is real value of 1, positive 1. So where will be the positive 1 real value? This is only no positive 1. So this is 1. So this point corresponds to omega is equal to infinity. Okay. So my graph will travel from omega is equal to 0 to omega is equal to infinity. Omega is equal to 0 to omega is equal to infinity. So let us try to compare which option is having these conditions. Option B will match with what we have obtained. So option B is the right answer for this question. If you see here, the graph is starting from omega is equal to 0, which is at 0, and it is traveling towards omega is equal to infinity. So graph path is also given by this arrow. It starts from 0 to infinity and it is ending at some finite value on the real axis, and that finite value we have already found, that is 1. Of course it is not given in the question, but you have got the graph. So any student, any average student is having minimum idea what polar plot, they will try to find out the answer for this question. Option B, that will be the right answer. But there is a lot of things that you have to understand. There is a lot of concept that you should be very clear about. Now I am telling you that I got conditions that at omega is equal to 0, this is my point. At omega is equal to infinity, this is 1. My graph will travel from omega is equal to 0 to infinity. Now, to travel from 0 to infinity, what are the routes available for me, or what are the roads available to me? You tell me. As given in this figure, as given in this option, my graph may move in this way. Or don't you think my graph can move like this also? Yes, my graph can go like this also. What is another road? My graph can straightly go like this also, no? Isn't it? What if in the options he has given you the remaining two conditions also? Which would be the right answer? Obviously, this is only the right answer. But how do you determine the direction of travel also? Yes, you have to find out what is the direction of travel also. So, to find out the direction of travel, now let me just enlarge this figure which we have drawn. So, these are the 2 points. This is the starting point and ending point. To reach from starting point to ending point, as I was telling you, there are 3 parts. Let us say I will take this middle path. That is directly on the real axis only. You will travel from this point to this point. You always keep in mind your polar plot or Nyquist plot will be on the real axis or the imaginary axis. Only on the axis, only if the system transfer function is having zeros or poles at origin. No finite zeros or not finite poles. If you look at this transfer function, you are having one zero at origin, but one finite pole is there. There is one finite pole. Finite pole means which is having some value. Let us say s is equal to -1 as per this. But s is equal to 0 means you are having some pole at origin, or on the numerator you are having some 0 at origin. So only when you are having either one pole or either some poles or either some zeros at origin, then you may get a graph which is along the axis only. But suppose you are having some bumps in this way or in this way, some kind of jumping is there. If the graph is jumping from starting point to ending point, that means there are some finite poles or finite zeros. It may be any number of zeros or any number of poles, I am not bothered. But I am telling you, for this graph, now you tell me, do you think the polar plot will be in a straight line? No, it will not be in a straight line along the axis. Why? Because there is a finite pole. So it should be either this bump or this bump, and direction is given like this because it starts from 0 to infinity. So when you are having finite poles or finite zeros, So your graph is starting at omega is equal to 0, your graph is ending at omega is equal to infinity. This thing you know. So for that you have to know in which direction the bump is starting. Okay, in which direction the bump starts and which direction the bump or the plot ends. So your graph is starting at one point and ending at one point. Now you have to find out in which direction the graph is going up or going down, or some bump you have to find out. So you are having two directions, that is called as starting direction, and you are having a end direction. If you know in starting direction and end direction, then you can find out which would be the actual path traveled by this locus. So first let us look at the end direction. To find out the end direction, for the end direction to be clockwise, your phase angle at 0, omega is equal to 0, must be greater than your phase angle at infinity. So if you look at this point here, for this graph here, at 0 omega, your phase angle is plus 90 degrees. At infinity omega, your phase angle is 0 degrees. That means your phase angle is greater at 0. That means your graph will end in clockwise direction. Your graph will end how? In clockwise direction. So you look at this option only, which is our answer. Where is the graph ending? This is the end point, isn't it? This is the end point. Now how the graph is coming like this? So graph is coming like this means what? Clockwise direction only, no, it is coming? Yes, it is ending at clockwise direction. Now to see the starting direction, you have to observe the finite poles or finite zeros. Finite poles or finite zeros. Which is close to origin, that will decide the direction. If a finite pole is close to origin, then the graph will start in a clockwise direction. If the finite zero is close to origin, then it will be anti-clockwise direction. Okay, the starting direction will be anti-clockwise direction. Now if you draw the pole zero diagram of this given transfer function, you are having a zero at origin and you are having a pole at a finite pole. Now you tell me which is close to origin, zero or pole. So we are talking about only finite, so you need not consider the zero. So don't take any confusion. Sir, 0 is on the origin only. You are telling which is close to origin. 0 is on the origin only. Why can't it be anti-clockwise direction? No, I am talking only about finite value. Finite value cannot be 0. It can be something above 0. So you are having finite how much? -1 is the only pole you are having. So you are having a pole close to origin, a finite pole. So the starting direction will be in clockwise direction. Okay, it will be in clockwise direction. If you see what is clockwise direction here, see, this is the starting point, isn't it? How the graph is starting? It is starting like this. It is starting in clockwise direction. It is ending in clockwise direction. Otherwise, I was telling you that there is another path that this may follow. That is like this. I was telling you, no, other bump was like this. If you take this bump, how the graph is ending? Graph is ending like this, isn't it? That means graph is ending in anti-clockwise direction and graph is also starting in anti-clockwise direction. So definitely this path is also not the answer. The only answer is like this. So this is how we are finding out in which direction actually the plot is traveling. Sir, in the exams we don't have time to make this table and find out what is what and all these things. Don't you think is there any short way to find out how to find out the plot? Just by looking at the transfer function, I want to identify the plot. That is what my idea is. Yes sir, there is a way. There is a way. Okay, what is that way means? First you have to understand on which angle does the plot starts. On which angle does the plot starts. So the starting of the plot indicated by the poles or zeros at the origin. How many poles are there at origin? 0 poles are there. How many zeros are there? 1 0 at origin. So you are having 1 0 at origin. So if you are having 1 0 at origin means then your graph will start at plus 90 degrees. Your graph starts at plus 90 degrees. See, after making the table also I am getting how much? Plus 90 degrees. Next, where will the graph end? That depends upon the net order of the system. Net order of the system. What do you mean by net order of the system? Net order of the system means what is the order of the numerator is 1. What is the order of the denominator? 1. So both order get cancelled out. What is the net order is 0. Net order is 0, no? That means the graph will end at 0 degrees. The graph will end at 0 degrees. Let us say you are having a numerator of order 1 and a denominator of order 2. So 1 get cancelled out. Finally you are having only 1 at the denominator. That means denominator order was 1. This indicates that the graph will end at minus 90 degrees. Suppose you are having reverse way. On the numerator you are having of order 2, denominator is of order 1. So 1 get cancelled in here. Finally you are left over with only 1 order in the numerator. That means the graph will end at plus 90 degrees. Like this, without actually having to find out this graph only, you can find out the approximate shape of the curve. So you got what is the angle, starting angle and finishing angle. And I already told you that if this starting angle is greater than the finishing angle, then the graph will end in, ending direction will be in clockwise direction. So don't you think this many conditions are enough, short tricks are enough to find out quickly the graph? Yes, definitely they are enough. And there is a small question for you. What kind of a filter does this system indicate over here? So you see, at omega is equal to 0, it is having a response of 0, magnitude is 0. At high frequency, it is having a response of some finite response is there. That means this given transfer function corresponds to a high pass filter. So this is a high pass filter. It allows only high frequencies. These are some important aspects of our polar plot, but this is not it. There is a lot of things that I will just discuss based on this question only. Taking only this question as reference, I will try to explore a lot of concepts regarding polar plots. I will end this video with this much. In the next video, we will continue with the same transfer function and we will try to analyze how this polar plot will affect the stability of the system also. At the same time, by addition of poles at origin, at poles at zeros, finite poles and finite zeros, how the graph is shifting, how the graph is varying, and what are the short tricks so that we can use to identify the graph immediately after looking at the question in the exam paper without actually having to draw all this table and all. Understood? Thank you for watching.